PHORBITECH stands for a toolbox for photon orbital angular momentum technology. That is the title of a European project approved within the Future Emerging Technologies program of the European Commission. Its main goals are to advance the science and technology of orbital angular momentum of light. This technology will have applications in the areas of information technology, in particularly classical and quantum communication, and in optical sensors and optical manipulation of small particles, for example in optical tweezers or in microfluidic devices. PHORBITECH team involves 6 European research groups from 4 different countries and 1 group from Brazil. Although invisible to the naked eye, a light beam such as that generated by a laser may have 2 forms of rotation, a spin and a twist. The spin is associated with the light polarization, and specifically with circular polarization. The twist is associated with the spiral shape of the wavefront and with an optical vortex on the beam axis. Technically, the first is called spin angular momentum and the second orbital angular momentum. The project team has produced several new or upgraded devices for the control of orbital angular momentum, including a very efficient sorter for splitting light according to the value of its orbital angular momentum, a device for generating light with orbital angular momentum directly from an integrated chip, and the so-called Q-plates.
The Q-plate is a liquid crystal device invented in Naples in 2006 that couples spin angular momentum with orbital angular momentum in a controlled way. This allows generating light with helical profile just starting from an ordinary laser beam. The Q-plates are at the core of the toolbox for quantum communication based on symmetrical photonic qubits, which are totally insensitive to any rotations.
The goal of our research is to develop new technologies for quantum information and quantum communication. In particular, we are interested in quantum cryptography, a new technology which allows to share a secret key between 2 partners, Alice and Bob. And this secret key can later be adopted to achieve the communication of an encrypted message. Usually, to carry out quantum cryptography, the 2 partners, Alice and Bob, send light between one partner to the other one, and the information is encoded in the polarization of light. But this scheme cannot work if the 2 partners are, for instance, 2 satellites which are rotating in time due to the motion around the Earth. To solve this issue, we exploit a different encoding, an hybrid encoding of the information, where we combine the polarization of light with the orbital angular momentum of the same photon. And this encoding allows us to achieve a quantum communication between the 2 partners, even if the 2 partners are rotating in time. This is the so-called alignment-free quantum communication.
PHORBITECH results are pushing forward the emerging photonic technology based on the light angular momentum. The most attractive future development might be the widespread use of orbital angular momentum for multiplexing the information in optical fibers. This may allow expanding the bandwidth of current networks by a factor 10 or more. The optical control of small particles in microfluidic devices might allow for developing new kinds of lab-on-chip devices, possibly useful for medical applications. Photonic sensors for controlling mechanical rotations or deformations could be utilized in high-precision mechanics or robotic devices.